We've discussed sets and counting with sets and the idea of whole numbers. Now in this next section, we're going to move on to addition and subtraction of these whole numbers. In general, when we're talking about addition and subtraction, and this will also extend to multiplication and division as well, but these are called binary operations. And a binary operation is when we take two whole numbers and combine them to form another whole number. So again, that's called a binary operation. It's because we're taking two whole numbers. That's what the by for that. We're going to start with addition. So when we talk about addition, we're finding the sum of two numbers. And as you all know, we represent it with the plus sign. So I want to define this first for sets. So when we talk about addition, we're going to start with two disjoint sets. This definition only works when the sets do not have any overlap. That overlap could throw things off. But if you have two disjoint sets, there's no overlap. When you're finding the sum of two numbers, you're basically counting the elements in the two sets, or in the union of the two sets. So if you look at the image that I have here, set A has a cardinal number of 3. There's 3 elements in set A. Set B, number of elements is 5. So if you want to add 3 plus 5, it's the number of elements in the union of sets A and B. So if you bring sets A and B together, there's a total of 8 elements. So 3 plus 5 equals 8. And that's our definition for addition. Again, I mentioned this in the last video, but you're not going to necessarily be going to this level of explanation for young children, but I want to give you the why behind what we're doing. I also want to give you 2 more terms. When you're adding 2 numbers, 3 plus 5, 4 plus 9, those 2 numbers, A and B here, are called addends or summands. So if you see either of those 2 words, that's what they refer to. It's the 2 numbers being added together. And there's a few properties for these whole numbers when we're adding them. And you might be familiar with these from past math classes, but we have what's called the closure property. That means if A and B are 2 whole numbers, then when you add A plus B, that answer, that sum is going to also be a whole number. The commutative property says that when you're adding, the order doesn't matter. So A plus B is the same thing as B plus A. The associative property, that deals when you're adding 3 numbers and you have parentheses involved, and it says it actually doesn't matter where you put the parentheses. So if I have A plus B plus C, if I add B plus C first, then add A to that sum, I'm going to get the exact same answer as if I add A and B and then add C to that sum. That's the associative property. And then the last one is the additive identity property of 0. It says if you add 0 to any whole number, you're going to end up right back where you started. 4 plus 0 is still 4, for instance. So those are some properties. And on the next page, I'm actually going to do these examples out of order. I want to start here with this last example where it asks which properties of addition are used. So the first one, I have 14 plus 18 equals 18 plus 14. That's the commutative property. It says order does not matter when you're adding. The second one, 12 plus 96 is a whole number. That's an example of the closure property. When you add 2 whole numbers, the answer is going to also be a whole number. Part C, 15 plus 0 equals 15. That's the additive identity property of 0. And that's going to take me just a second to write. And the last two actually are going to illustrate two properties each, and it's going to be the same two properties. So I have 17 plus 14 in parentheses plus 13 equals 30 plus 14. So there's a couple things that are happening here. One, the order is changing. The 14 went from being in the middle to being at the right. So that's our commutative property. And the parentheses, instead of being around the 17 and the 14, we're around the 17 and the 13 to get the 30. So this is highlighting both the associative and the commutative properties, as is the last one. So I'm just going to write these twice. Or sorry, write these once since it's for both of them. Oops. Not associate, associative. So in our last one, we have 12 plus 15 in parentheses plus 5 plus 38. Again, there's a bit of reordering happening here. This 50 comes about from adding 12 and 38 and the 20, 15, and 5. This is a bit of a shorthand way to add, something we'll talk about in more detail later. So both of those last two are using the associative and commutative properties. Now I want to go back up to the two examples that I skipped. The first one, we have sets A, B, and C. Set A is apple, berry, peach, B is lemon, lime, and C is lemon, berry, and prune. It says, find the number of elements in A union with B. So when we union A and B, we're going to have apple, berry, peach, lemon, lime. So we're going to have a total of 5 things. So the number of elements in A union B is going to be 5. Second one is the number of elements in A union with C. So A is apple, berry, peach. C is lemon, berry, prune. Since berry is in both, we're not going to count it twice. So the union of A and C is just going to be apple, berry, peach, lemon, and prune. So once again, 5 elements. And then our last one, the number of elements in B union C. In this case, lemon is repeated in both sets, so we only count it twice. So the union of B and C is going to contain lemon, lime, berry, and prune, so 4 elements. So you can see, because these sets are not disjoint, because there's overlap with A and C and with B and C, hopefully you can see why the sets have to be disjoint when you're using them for addition, because otherwise you'd have 3 plus 3 equals 5. Okay. Our last example here, it says illustrate 5 plus 3 with a number line diagram. So we're adding, we start with 0 here, we're dealing with our whole numbers. So 5 is going to jump us to right here. And then we're going to go another 1, 2, 3 to that, just counting over on our number line. So that shows us our answer is 8.